Hey guys, welcome to my first ISLM video. Although this one's not really ISLM, it's about the Keynesian Cross. But that's an important part of it. So here's what we're going to do. We're going to review the Keynesian Cross. I'm going to be a little bit more advanced than I would do in like a principles course. And we'll talk about the spending and the tax multiplier. And then in the following videos, we'll really dig into the ISLM. So if you don't want to watch a Keynesian Cross video, you can go to part 2 and have fun. Here we go. So some preliminaries. Let's lay out notation. Now I'm borrowing notation from the ManQ macroeconomics text, just so you know. So we have I, which is planned investment. And then I separate it more than the book does. I use unplanned investment, so that's IU. And there's actual investment, which is IA. The book only just did I, but I like to keep all three of them clearly separate. IA is equal to I plus IU is equal to the planned investment plus the unplanned investment. Now what's in planned investment? Well, that's all the stuff that we normally think of. Tools, equipment, etc. The stuff that depends on interest rates. What's in the unplanned investment? That's usually just unplanned inventory changes. We made a bunch of stuff. We didn't sell it this year while we were measuring GDP, so it just gets counted as investment. And then we have planned expenditures, which is PE, and PE is equal to consumption plus planned investment. So remember, I is planned investment plus G. And we are in equilibrium in our macroeconomy if planned expenditures equals GDP. So another way of saying that is if actual investment is equal to planned investment. Another way of saying that is if there is no unplanned investment. So here's our graph, the Keynesian Cross model. And again, if you want to get a more thorough treatment of this, you can go to my principles level video. It's like 16 minutes long and goes a little nuts. But yeah, we've got the planned expenditures curve, which is this flatter one. And we've got this 45-degree line. And that, its only purpose is just to help us to see where we are. It's a reference. It tells us every point where y equals PE. Wherever the equilibrium is, it has to be on that 45-degree line, because those are the only points where y equals PE. So y equals PE at y star, and y star looks something like that. Boom. Notice, same coordinate on the x and y axis because they're on the 45-degree line. At this point, we have no unplanned inventory investment. Businesses are selling the stuff that they make, and that's a model of a market in equilibrium. Now let's look at a low GDP, where that planned expenditure is greater than GDP. Because the PE curve is greater than the 45-degree line, that means PE is higher than Y. Well, in this case, we have to have negative unplanned investment because real GDP is less than planned expenditure, and the only difference between them is the unplanned inventory investment. So in this case, negative unplanned inventory investment means that our inventories are falling, all of our stuff's going off the shelves faster than we thought, and so our businesses are going to increase production, which will increase GDP, which will bring us towards equilibrium. Likewise, if you have a high GDP starting point, you're over here, where real GDP is higher than planned expenditures. This is only possible if you have positive unplanned inventory investment, which happens when inventories are piling up, which means our firms are going to start to slow down their production to sell what they have, and it means that GDP is going to fall. So let's add some math to it now. We're going to have some consumption function. It's going to be a function of disposable income. We're going to have some exogenous G. We're going to have an exogenous tax level. We're going to have exogenous planned investment for now. We'll change that later. Let's see. And let's do an example in green. Here's a specific consumption function, MPC times y minus t. And specifically, let's make the MPC be 0.5, just for fun. G is 500, T is 400, I is 450. And we're only going to let that one be temporarily exogenous. Don't worry, in the next video, when we make it be a function of r, we'll be able to build the IS curve. So planned expenditure looks like that. C plus I plus G. And if we substitute in our stuff, we know this y star is there. And that happens, we know this y star is there. So let's figure out our planned expenditure function and we'll graph it on there so that they cross right at that point. 0.5 times y minus 400 plus 450 for I plus 500 for G. I've just substituted in all those numbers, nothing else. Let's condense it all, and it comes out to be 0.5y plus 750. And now we can graph that if we want to. It looks like this. 750 there, and it's got a slope of 0.5. By the way, the MPC will always be the slope of that line. Alright, so what is the equilibrium y star? Well, that's where PE equals y. We've shown it on a graph. How do you solve for it? You just set the PE equal to y. We solve for the planned expenditures, set it equal to y, solve for y, and in this case we get 1500. There we go, equilibrium y. Woohoo! We've mathed it. Now, what if there's a change in government spending? What if it goes up by 200? Let's see, government spending would go up to 700, which would give us a new planned expenditure curve of 0.5y plus 950, which if you set that equal to y and solve for y, you get 1900. There's something crazy. It goes up by 200 for the planned expenditure line, and then our GDP goes up by 400. GDP went up by more than government spending. So why is that? That brings us to our multiplier conversation. So we know y equals c plus I plus g. Change in y is equal to change in c plus change in I plus change in g. If g changes, what happens in our model? Change in y is equal to change in c plus change in g. And the reason we say that is because I is exogenous. It's not changing. So it doesn't have a change unless we say it does. So that means change in y is equal to MPC times change in y plus change in g, because the rate of change for consumption is MPC. That's the definition of MPC. So change in y and change in y shows up two places in this equation. Let's solve for change in y, and we can see how much GDP will change by. 1 minus MPC times change in y equals change in g, which means change in y is equal to 1 over 1 minus MPC times change of g. This is a huge deal. This little piece right there, 1 over 1 minus MPC, has a special name. We call it the spending multiplier. And the spending multiplier helps us to know how much impact our government spending will have on GDP, and it will help us to target good fiscal policy. Back to our example, if this is our planned expenditure line, and we knew that Y1 was 1500, we could change government spending by 200, same MPC. Let's see if it gets us up to 1900. Let's see if our change in Y is 400. Change in Y is 1 over 1 minus MPC times change in G. So change in Y is equal to 1 over 1 minus 0.5 times 200, which is 1 over 0.5 times 200, which is 400. Boom, it worked, because that is the same as this increase from 1500 to 1900. So note that this 0.5, if you're ever looking at the equation and you're not sure what the MPC is, it's the slope. The thing attached to the y, that's the MPC. And this equation, it's a big deal, because it links our government spending to our GDP. So remember, Y2 is 1900, Y1 was 1500, and so Y1 plus change in Y, so 1500 plus 400, that comes out to 1900. Okay, now what if we cut taxes by, say, $200? Different policy. Y equals C plus I plus G. There's our little equation with all of the information plugged in. And let's see. Substitute through with the parentheses, blah, blah, blah. You get Y equals 1,700. So we cut taxes by 200. GDP fell by 200. Let's see, where does that come from? Y, change in Y is equal to change in C plus change in I plus change in G. Change in Y equals change in C. Because those two are both exogenous, neither one of them will change unless we explicitly change them. When we change G, G changed. But if we're not explicitly changing G, it doesn't. So, change in Y is equal to is MPC times change in Y minus change in T. Change in Y is equal to MPC change of Y minus MPC change of T. And now we're going to solve for those change in Y's again. 1 minus MPC times change of Y equals negative MPC times change of T. So change in Y is equal to negative MPC over 1 minus MPC times change of T. So this thing is what we call the tax multiplier. It's different from the spending multiplier. They both have the same denominator because they're doing similar things, but they are different. Change in GDP is equal to minus MPC over 1 minus MPC times the change in tax, which is minus 0.5 over 0.5 times minus 200. That comes out to be positive 200. And sure enough, we had a change of GDP of 200 earlier because it went from 1,500 to 1,700. All right, let's compare these two multipliers. Tax multiplier is that. Spending multiplier is that. Tax multiplier is negative. If you raise taxes, GDP will fall. Spending multiplier is positive. If you raise spending, GDP will rise. And the spending multiplier is larger in absolute value because a 1 in the numerator is bigger than an MPC in the numerator. Let's end by comparing a $400 tax cut to a $400 spending hike. We'll do a different MPC just for good measure. Let's say the MPC is 0.6 minus, let's get our tax multiplier, minus 0.6 over 1 minus 0.6 is minus 1.5. Based on that, I can get my change of GDP, the multiplier, times the change in taxes, comes out to be 600. Spending multiplier is 1 over 1 minus MPC, times, so that's 2.5. Change in GDP is 2.5 times the change in spending is 1,000. Okay, so they change in different directions because that was taxes decreasing versus spending rising, and the amount is bigger. So I hope that's a helpful crash course or review or whatever you want to call it. We just added a little bit of math to our Keynesian Cross model. And again, if you want more details on the Keynesian Cross, head on over to the other video in the description. Thanks for watching, guys.